In this lesson, we shall look at mathematics, right? And we shall focus on mathematics 141, math 141, which is our math module, focusing on the part on conic sections. Sketch the parabola, identify the focus, vertex, and directrix. And we remember we discussed this yesterday, so we shall not obviously delay a lot. You already know that our y squared must be equal to 4px, which means y squared is equal to, if a y squared is 6x, we take out 6 so that our p is 6 divided by 4, which is 3 out of 2 x. Right, and this sort of gives us our p. So that at this point, you can write this as y minus 0. You square it, 6, 3 out of 2, and then x minus 0. Right, and then we need to sketch, of course. So sketching these, x and then y. Then you'd have the following. Okay, this is going to be 0, 0. Because it is y squared equal to this, which, because y squared is positive and this is positive, x is positive this side, which means that it opens right. Right, opens to the right. Right, so you can write that actually, because of that, it opens to the right. Right, if it opens to the right, then you have this. Okay, now, when it opens this way, then there's a point that is sitting here that is going to be the same distance, which is 3, 2. I started with the x. It's going to be 3, 2, and then the y is going to be 0. And this point is called the focus. All right, it's called the focus. And then now there will be a point that is the same distance away from the origin as the focus, 3 over 2, but it is on this side, which means that it is here, which is x equals minus 3 over 2. And this point is called the directrix. Right, so you have the directrix, and this directrix is x equals minus 3 out of 2. We shall go back to the other things, please. Right, so now directrix is there. Our focus is this one. So our focus, because of the p, which is 3 over 2, our focus is therefore 3 out of 2, 0. Our vertex, the origin, is the origin. So I believe that this is straightforward. It's something that has become so easy to you at the moment. And then we are able to, right, we're able to continue then and understand this. Let us look at the following. Let's look at part B. Here it's part B. So now this one, because it's x squared, you can look at it as x squared, which is minus 4py. like this. So which means that P itself is going to be a positive number, so it's going to be 9 out of 4. Which means that it is x squared equals, if you put minus 4 like this, it's going to be 9 out of 4 and then y. 9 out of 4 and then y. Right, so 9 out of 4 and then y. So that at this point, then you have the P is that one. And then you can write this as x minus 0 squared minus 4, 9 over 4, and then you write y minus 0. Right, so we're able to see what is happening here. So which means, therefore, if we have this, we have the following. Be able to then analyze this and see that what we have here is that we can sketch the graph of this. Because it is x squared that is equal to this, and this thing here is on the negative side. It's on the negative side, which means that the x squared is like on the negative side of the y. On the negative side of the y. And the negative side of the y is the bottom, because this is the positive side of the y and the negative side of the y. The negative side of the y. Right, so that so we have exactly the following. Right, on the negative side of the y, it's this one, and therefore the graph is going to be going to the negative side of the y. Like this, because you have the negative side of the y. So, and as a consequence, it opens downwards. Opens downwards. But now, as it opens downwards, we'll have our focus, which is sitting here. According to this, which is actually exactly the 9 over 4, but this 9 over 4 is actually on the at the bottom, so it's going to be actually exactly 0 and minus 9 over 4 for the y. Okay, so we continue. We continue. Then there's going to be a directrix. Right, that's a good question. How do we know which side it opens? You look at the side of the y, or you look at the right hand side, you know, because at this point, because it is minus 4py, it's minus 9y. It's minus 9y means that y is negative. Y is negative. So if y is negative at the bottom. Right, so that we have exactly that. So that we have y and then x. So obviously then we continue with that exam. Okay. So now you'd then be in a position to then say, okay, it is actually downwards like this because y is negative, is minus 9y. It's minus is minus 9y. So y is negative downwards. Okay, so that's why it opens downwards. Okay, now because of the fact that now this is 0 and minus 9/4, because the focus is going to be at p equals 9/4, but it opens downwards so that it's negative 9/4. And then directrix is going to be the same distance away, so it's going to be 9/4 upwards, but it is y, which means y is 9/4. And this means, therefore, we have the focus. The focus, therefore, is 0 and minus 9/4. And then we have the vertex, 0, 0. And then we have the directrix. The directrix. Which is 9/4. 9/4, which is the directrix. 9/4. So now think about this one and make sure you understand it. Right, think about this one and make sure that you actually understand it. Right, so think about it and make sure that you actually understand it. All right. Make sure that you're able to understand it. Right. Make sure that you understand it. Right, so we move on to the next question. It is our hope, therefore, that this is very clear. And we're able to understand everything about this particular question so that you're able to see the vertex. We're able to see the directrix, and we're able to see our focus as well. We're able to see our focus as well. Right. Okay. So we continue. And obviously then we look at the next question. Okay, now we're going to revisit 4C. Right, looking at 4C, we have exactly the following. You see, it is y plus 1 which is x minus 4. Right, so now we would have this one, which is the same as y minus 1. You square this. And this is therefore minus 7. And then you're going to put the fact that you need to put a number here. So which means that the P is going to be the 7/4. Okay, and then this is going to be x minus 4 in line with y minus k squared, which is minus. So yeah, here I meant that you need to put a 4 here. Right, so you need to put a 4 here. Right, so that you put minus 4p x minus h. Right. 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 Okay, so we continue then, and we're going to have this. So let us sketch this graph here. Let us draw this graph. So sketching this graph, you need to look at the following. But because y is equal to a negative, y is a negative, and there rather x, the x minus 4 is associated with a negative. So x is negative this way. So because x is negative this way, and then x is positive this way, so this one means that it opens on the side. Right, we're saying that it's minus 7x, so x is negative. It's like minus 7x. Minus 7x. Okay, because it is minus 7x, it then means that because x is negative, well, it's minus 7x. So now x is negative on the left, so it opens to the left. Right, it opens to the left. Right, it then opens to the left. So it's gonna be like this. But now we must check carefully the vertex. So the vertex is going to be at x equal to 4. And then y is negative 1. So x is 4, and y is minus 1. Okay, so this is the vertex. Right, this is the vertex which you can easily read off from the graph, from the equation. Because x is negative, and x is negative on the left of the origin. So it means that it opens to the left. Okay, now we analyze these together and make sure we have the following. We have exactly the following. Right, we have exactly the following. Right. Right. Right, so we continue with our analysis of this particular question. Continue with our analysis of this particular question. And then now, if you continue with our analysis of this particular question, you'd have exactly the following. Right. Right, we continue with our analysis of this particular question. So now, if you look at these, we're going to sketch this graph carefully, of course. So the way we're going to sketch this graph we're going to look at a couple of things that are important. Right. So we continue. Okay, y'all, this is the vertex. Then our P is 7/4. Our P is exactly 7/4. So that now the P tells us we're going to measure the distance, right? The distance from the vertex to the focus, the distance from the vertex to the directrix. So we continue. We continue. Right, so we continue. Right. We continue. Right. So now you'd have the following. We're going to have exactly the following. Okay. Right, we're going to just measure P. So now, if we measure P, because it opens to the left, but the number is 4. So you're going to have 4 minus, because you're going to move to the left, 4 minus 7/4. 4 times 4 is 16, minus 7/4, which is 9/4. So we're going to be, the vertex is going to be on the axis of symmetry. The axis of symmetry through the vertex. So that you have the distance that is going to be like the 4 minus 7/4, which is 9/4, which means x is 9/4 and y is -1. So this one would have to give us the focus. To give us the focus. But now the directrix will have to be plus. So the directrix is going to be on this side. If it's going to open like this, then we're going to have the directrix. The directrix is going to be 4 plus 7/4. Right, so 4 plus 7/4, which is exactly 16 plus 7/4, which is the same as 23/4. Okay, so we're going to have like this one. And this one is going to be at exactly 23/4 for the x, and the y is -1. Okay, so that's okay, but remember, directrix must just be given as the vertical line for this kind of a graph. So it's going to be like this. So X is going to be 23 out of 4 for the directrix. But now there are two things. What is the x-intercept for this one? So when y is 0, you're gonna get x. So it's 1. When y is 0, then you're able to get the x-intercept. When y is 0, which means you have minus 7x plus 28. Which means that it's minus 7x equals minus 27, which is 27 over 27. 27 over, which is 7 out of 27, excuse. Which is like 27 over 7, yeah? So you're going to have that x is 27 over 7. 27 over 7, which is like, 3 point something. That is the x-intercept. It's going to cut like this. As it opens to the negative x, and the negative x is that way. And then obviously by symmetry, then it's going to be like this. It's going to cut through wherever x is 0. Then you're going to have y plus 1 for x 0, y plus 1 squared. When x is 0, then this is 28. Y plus 1 is plus or minus 2 to the square root of 7. Plus or minus 2 to the square root of 7 minus 1. Yeah, so you have now 2 times 7, the square root of 7. Square root of 7 is like close to the square root of 4 because it's more than the square root of 9, which is 3. So it's 2 point something, closer to the square root of 4. Between the square root of 4 and 9, that is 7. So it's 2 point something. 2 times 2, it's a 4 minus 1. It's a 3 point something, which is going to be here. So this one is going to be 2 to the square root of 7 minus 1. And then there's going to be another one at the bottom. Minus 2 to the square root of 7. Right, so it's minus 2 to the square root of 7 minus 1. Okay, these would give us the x-intercepts. So which means that we have had the focus, which is the square, which is 9 over 4 and minus 1. The vertex is exactly at... so the vertex we've already seen already. It is at x 4 and y minus 1. We have seen the focus. Right. What is the focus? The focus is this one, which is 9 over 4. And then the directrix. All right, the directrix is exactly what? It's x equal 23 out of 4. 23 out of 4. Okay, yeah, that's what we have. Okay, so yeah, this is what we got. And we'll sketch this particular graph here. This graph opens to the left. Why does this graph open to the left? Because we have minus 7x, minus 7x, minus 4. So meaning that it opens on the negative x, on the negative x. Let's move on to the next question. And x is negative on this side, on the left. So it opens to the left. Because x is negative on the left of the origin. Right, it is negative on the left of the origin. It's negative on the left of the origin. Right, let's move on to the next question. Okay, here's another question that is like x minus 1/2 squared 2y minus 1. So this one is a formula. It's x minus h. The square root is 4. It's actually exactly 4p y minus k. Okay, this is the formula we're going to use. But because it is 2y, so y is positive upwards. So in other words, this one is going to open on the fact that there's a plus 2y, so it opens on the positive y. So if this is the case, and then y is positive here, and then y is negative there. So it means that it opens upwards. All right, so it opens upwards. All right, opens upwards. Right, because of the fact that y is positive upwards. Okay, because there is a positive 2y. Now, we actually obviously will like focus on what we do here, but let us find the easiest things, like let us find the directrix and so on, and the focus and the focus. Right, and the focus. So we continue. We continue. We continue. Right. We continue. Right. So now let us see the vertex. Yeah, so we're saying this equation from here to this. You're going to pull out 4. You pull out 4 out of this, so which means that the P is going to be 2 out of 4. The P is going to be 1/2. So let's say the 2 divided by 4. So it's going to be 1/2. And then y minus 1. We're done with this one already. So now we need to just find some things. Right. So we'd have exactly the following. You'd have exactly the following. Have exactly the following. Right, so you'd have exactly the following. So we continue with our analysis of this, sir, please. Right, you continue with our analysis of this. Um, Okay, our P is 1/2. But let's find first our vertex. It's easy to get. So our vertex is the easiest one because it's already given from the equation. So vertex is going to be x is 1/2 and then y is 1. This one. So x is 1/2 and then y is 1, which is this one. So, but now because it opens upwards, so we're going to have this. Right, we're going to have this. Okay, so it means that y is actually, rather x is 1/2 is the line of symmetry. But if we have that our P is 1/2, then you must add 1/2 to go to the top. So if it's 1, we add 1/2, which is 3/2. So 3/2 is going to become the focus, right? But the y is going to be 3/2. The x will remain 1/2. The x will remain 1/2. And then you subtract going down. So which means that, yeah, which means that you're going to have, yeah, here we're saying that this line of symmetry is the axial symmetry is x equals 1/2. So that if we have our y equals 1 through this, then we go down according to P, half units. So which means that 1 minus 1/2, from 1 we subtract 1/2, we get 1/2. And this is going to give us the directrix. Going to give us the directrix. So the directrix is going to have the equation y equals 1/2. Which means the vertex is 1/2 1. The focus, we added 1 just to go up 1 above y. So which means that x will remain 1/2 and then y we added just 1. We added half to 1 to go up, which means that the focus is 1/2 and 3/2. The directrix. Right, so we have the directrix. Right, so the directrix. The directrix is going to occur at what? Right, it's going to occur at y equals, yeah, at y equals 1/2. How do we know y equals 1/2? We subtract 1 from the vertex. We always go 1 unit into the vertex, above the vertex, and then 1 unit below the vertex, according to P, because P is 1/2. So you go 1/2 up and then 1/2 down. Right, so we have exactly the following. So we have exactly the following. So we have exactly the following. Right, so we have precisely the following. Right. So we move on. So we continue. So we have exactly the following. Right. We continue. So we've sketched this one, and then now we move on to the next thing. Let's check the next question. Let us see the next question. Okay, the next question is about the ellipse. It's about the ellipse. Now, we were dealing with the parabola before, but now let us deal with the ellipse. The ellipse is very, very important to us. And now we need to understand the ellipse also. We need to understand the ellipse as well. So the question is, how do we deal with the ellipse? Right, how do we deal with the ellipse in this case? Right, so there are two kinds of ellipse that we study. Right, so the ellipse is given by two kinds of graphs. Let us talk about the graphs that pertain to the ellipse, and then we shall sketch the ellipse. But now let us look at some properties of the ellipse. Right, obviously, I want us to look at what we call the translated conics. Translated conics. Right, which means that the ellipse is going to be x minus h, you square it, divide by a squared. Y minus k, you square it, you divide by the b squared. And this is the following. So this one is going to become 1. And then it's b less than a. Okay, so now if b is less than a, this one is called the ellipse. It's called the ellipse with center. It's called the ellipse with center h and k, and measure axis. And measure axis parallel to the x-axis. Parallel to the x-axis. Parallel to the x-axis. Parallel to the x-axis. Okay, so we have exactly that. So now you're going to have, okay, so there is kind of ellipse that is translated, which is the general thing. Okay, this one is centered at the origin, so it's easier. But yeah, we're looking at the general one because we're going to look at more ellipses, not just one. Right, so the ellipse with center HK and measure axis parallel to the x-axis. Because here A is bigger. So if A is bigger, it means that you're going to have your x. Your x is bigger. Right, so if your x is bigger, then means that your graph is going to be like this. It's going to be like an egg that is lying down. Something like that, because the x is bigger. The A is bigger, then A is bigger, X is bigger. And then the Y is smaller. So it's smaller on the Y. Okay, we're discussing properties of the ellipse. We're discussing properties of the ellipse. Discussing properties of the ellipse. We're discussing properties of the ellipse. Okay, now we're going to have another ellipse that we need to learn as well. There's another ellipse that you need to understand. Right, so the other ellipse that you need to understand is the following ellipse. Okay, because we're going to learn just two types of the ellipse. There is this one that is still x minus h. You square it, but it is b squared. So now we have a b squared under the x, and then you're going to have the y minus k squared. You divide by a squared. Now the a is always the biggest one, equals 1. And in this case, the a is always the biggest one. And in this case, we're then saying it is still b minus b less than a. So b less than a means therefore that a is the biggest one. If a is the biggest one, so this one would be b less than a. A is always the biggest one, but you can see that a is on the x side. But now the a is on the y side. So the graph is going to be like a standing ellipse. Right, with still b less than a, but the y is bigger. So the y is bigger means that the a is on the side of the y, like an egg that is standing up. But now this description focuses on the ellipse with center. With center HK. And right, so with center HK, right, with center HK and major axis. Right, so now let's talk about it. And major axis parallel to the major axis parallel to the biggest one. So it's parallel to the, because now the y is bigger, so it's parallel to the y-axis. Parallel to the y-axis. Okay, so but now there's more we need to discuss about the ellipse. Right, there's more we need to discuss about the ellipse. This ellipse is going to have its focus. Right, it's going to have its focus. Right, it's going to have its focus. is going to have its focus. Right, so now the focus is going to be given as follows. Right, so we're going to have the focus. Right. Or what we call the foci, because there are two of them. Right. The foci will occur at c equals the square root. All right, so now we have c equals the square root of a squared minus b squared. C equals the square root of a squared minus b squared. So now, if this is the case, we continue with our analysis of this. We continue with our analysis of these. Right, so that is the formula for the foci. Right. That becomes a formula. But again, this is the formula for the foci because A is always bigger. A is always the biggest one. So if A is always the biggest one, then you say the biggest one minus the smallest one. So it's A squared minus B squared. Right, so we have this. Right, we have this. We have exactly that there. So now let us look at an example before we start with these ones. Before we start with these exercises from the chart, I'm going to give an example. Right, that is nice and easy. Then we're going to start with the chart. So, for example, let's look at this ellipse and then we need to find everything else. So if you have x squared, you divide by 9. And then you have y minus 3. You divide by 16. And the result is 1. X minus 2 squared. You divide by 3 squared. So this squared, you divide by 4 squared equals 1. Right, so at this point, we know that it must be B less than A. A is always the biggest one. Which one is the biggest one here? Right, which means that the biggest one is 4, which means that A is 4 and then B is 3. Okay, because always B less than A. Always. So you choose A to be the biggest one, which is 4. And then with this, then we're going to, of course, sketch this. But what is the, where are we going to have the foci of this? Right. So the foci lie okay. Okay, let us deal with the foci first. Let us say more. The formula for the foci is a squared minus b squared. The a is 4 squared minus 3 squared. What is 4 squared? 16 minus 9. What is 16 minus 9? It is 7. So c becomes the square root of what? C becomes the square root of 7. Okay. But so because of this, then we say therefore the foci lie the square root of 7 units above and below right, so above and below the center. Above and below the center. All right. So now, this is what you're going to have. Above and below the center. So now, let us draw a rough sketch of what is happening here. For this ellipse. So if this is the ellipse, but right, this is what we have. So when we do this, then we can see that it is x minus h squared over the smallest one is the b. The biggest one becomes the a. So it is this one over the a squared equals 1. So we continue. We continue. Right, so if then we continue, we have exactly the following. We have exactly the following. They have exactly the following, yeah? So, right, we have exactly the following. Okay. Let us see what we can do here. Let us see exactly what we can do here. Okay. Okay, we check what we need to do. Right, we check what we need to do. Okay. So the biggest one is always the A. So this gives us the major axis and also the minor axis. And we're going to write in red and say thus. Because at this point, it would mean that H is for the X always. K is for the Y. The biggest one is A, which means A squared is 16. And then the smallest one is B. The smallest between 16 and 9, which means that B squared equals 9. But if you take the square root of 9, the square root of 9 is 3. So you have that B is 3. And then yet A is what? It's 4, because the square root of 16 is 4. Okay. But now, okay, we're just discussing the ellipse. It's very easy to discuss the ellipse. So thus the graph. All right. Thus the graph of the equation is an ellipse. It's an ellipse with center. Right, with center. Right, it's an ellipse with center 2, 3, because H is 2 and K is 3. And major axis. Right, major axis. The major axis parallel to the y-axis. Okay, because it is longer on the y, because y is bigger. It's longer on the y. So it's like a standing egg, like this. So which means that the major axis is parallel. The major axis, this one here, is parallel to the y-axis. Major axis parallel to the y-axis. Parallel to the y-axis. Major axis parallel to the y-axis. Major axis parallel to the y-axis. Okay, so okay, we continue with this particular question. All right, I'll just giving this one. The foci lie the square root of 7 units above and below the center. So we're going to analyze this one. Right. But I want to say also, since, right, since, okay, let's look at the since part and just say more about this ellipse. Since A is 4, we've seen that A squared is 16, B squared is 9, and then A is 4, and then B is 3. Since A is 4, the major axis extends 4 units. Extends 4 units above. And 4 units below the center. Below the center. So its endpoints. Right. So its endpoints Right, its endpoints are right. So if the center, we're going to analyze that. The center is 2, 3, and then now since the A is 4, which is the biggest one, so it means therefore the major axis extends 4 units above and 4 units below the center. So its endpoints are 2, 7, and 2 together with -1. We're going to analyze that. Okay, let us analyze this graph here. So what is the center? The center is 2, 3. X is 2 and then Y is 3. So the center is this one. 2, 3. 2, 3. If the center is 2, 3, and then since A is 4, the major axis extends 4 units above and 4 units below the center. So you're going to say 4 units above. So when you're here, you go up, you add to the Y, and the Y is 3, and now you're going to add. So which means that you add 4 units. If you add 4 units, the X is the same, 2, and then Y is going to be 7. And then 4 units down. This one is already 3 units, and then you must go 1 unit down. Which means you go down, the X is 2, and then it's -1. Like this. Right, so we have the following. We have exactly the following. Right. We have exactly the following. Yeah, so yeah, this is what by and large you're going to have. So, but yeah, we are still continuing with our analysis of the ellipse and then, right. So we shall look at more things. Let us analyze what is going to happen with the minor axis. What is going to happen with the minor axis? Right, obviously we know that since B is equal to 3, the smallest one, is smaller than 4. Since B is equal to 3, right, it means that there's something called the minor axis. The minor axis extends the 3 units left, because the B is 3 units left, 3 units left of center, 3 units left, right, 3 units left, and 3 units right of center. right of center. Okay, let us deal with the minor axis now. So because the B is 3, then you're going to measure 3 units. But here already this is 2, so which means that 3 units is going to be -1. This is going to give you the point x equal to -1, and then y is 3. From the center to 3, B is 3, so you add 3 units to the x. And then the x is already 2, and then you add 3 units, and then it's going to become 5, 3. Okay, like so. Okay, we're just discussing the ellipse a little bit. So now, which means this is the graph. So it's going to go here. And then let's make it red. And then it's going to go down. All right, it's going to go exactly down. Right. All right, so you continue. So it's going to go like this. Okay, yeah, it's sort of this. Yeah, but it is sort of like this. Yeah. Yeah, but it's not to scale. It's longer vertically. It's longer vertically. It's longer vertically. Right, so this is what we have. Right. But if this is the case, then we're gonna actually still, where do we have the foci here? Because seeds, this one, the foci lies square root of 7 units above and below the center. So now you're gonna have, this is the center, and then you're gonna go below and above. So it means that the foci is gonna be like here, which is gonna be, x is gonna be the same, which is 2, but y is 3 minus the square root of 7. 3 minus the square root of 7. So this one is going to become the actual new position of the foci. Okay, so we have another one. So that you have 2, 3 plus the square root of 7. 3 plus the square root of 7. So you have the foci in 2 places. You have a focus here, another one. So there are 2 of them. So in other words, this one is a focus, and then this one is another focus. All right. And then we've sketched this one here. We note that the actual equation of these is 16x squared plus 9y squared minus 64x minus 54y plus 1 equals 0, like this, or like so. This is the equation, but through completing the square, this equation can be transformed into this one, and then we can be able to sketch it and see what we can do there. And see what we can be able to do here. So we continue with our analysis of these. We continue with our analysis of these. So, okay, it's not the question we are doing, but we're just doing a general question, and then from this, everything is going to be easy. That is the point. Everything is going to be straightforward from this. Okay, let us try 5A. 5A is very straightforward. There are two things we need to look at as we're actually trying to examine this ellipse. We need to first examine the h. So the general formula is x minus h. We're looking at the general formula. And now you decide which one is the biggest, because in each case it's always b less than a. So a is always the biggest one. So we saw that it's always b less than a. So a is always the biggest one. So in this case, why it's big? Because 25 is big. So which means that here you're going to have the b squared. And then the y minus k squared, you divide by the biggest one, which is the a one. So this is the formula we're going to use. And then writing that one out, we're going to have the following. X minus 0, you square it, you divide by the 2 squared. Or simultaneously, because of this, you're able to see that the b squared is 4. The a squared, the biggest one, is always a, which is 25, which means b is 2, a is 5. Okay. So this is what we are getting. This is what we are getting. So, which means that obviously then we're going to have the 2 squared, y minus 0 squared, you divide everything by the biggest one, which is 5 squared equals 1. Okay, so now, which means at this point we can see that h is 0, k is 0, a squared is 25, the biggest one, b squared is 4, the smallest one. This means that we can be able to get the center. The center of the ellipse is 0, 0. Okay, if you get the center of the ellipse at 0, 0, then we have also some other things. Then we must get the value of c here. So for the ellipse, we know that c is the square root of the biggest one, a squared minus the smallest, b squared. A squared is 25 minus 4, which is 21, excuse. Which is going to be exactly 21. So C becomes the square root of 21. This C is going to give us the foci. Going to give us the 2 foci. Okay, the foci depend on the center. So you actually, obviously, you take the center and then you... So you describe this ellipse because y is bigger. So it means that it has its major axis. Right, so So now you're going to deal with the biggest one. So you say the biggest one, and this is how you put it. Since A equals what? Since A equals 5 and is the biggest one, and the biggest one is for the y, it means the measure axis is parallel to the y-axis. Right. This implies that the measure axis right measure axis parallel to the y-axis. Measure axis parallel to the y-axis. Measure axis parallel to the y-axis. Okay. So why do we have the foci? Because if the measure axis is parallel to the y-axis, it's going to be longer like this. The graph. The ellipse. Okay, it's going to be longer like that, vertically. Okay, if it's longer this way, then you're going to take the origin. So the foci are, you take the center, and then vertically you subtract, you add the C. Right, so because you're going up, so you're going to add to Y. So you're going to have 0, and then you have 0 plus the square root of 21. Which means that you're going to have 1. Yeah, so you're going to add or subtract the square root of 21. It's okay like this. So which means that this one is going to be plus or minus the square root of 21, and this will be the foci. Okay. And then now we need to find the vertices. The vertices are gonna deal with the merger axis. We've already said the merger axis is the one that is obviously on the vertical, and at this point you're gonna have exactly the measure axis, which is the y-axis. The measure axis becomes the y-axis, and therefore we have the vertices on the measure axis. Now to get the vertices, you look at the center, and then you look at the biggest one. What is the biggest one? The biggest one between the A and the B, it is the A, which is 5. So which means that you're gonna take the center and add or subtract 5, so that it is actually 0 plus or minus 5. 0 plus or minus 5. 0 plus or minus 5. So we continue. We continue. So we continue. So we continue. Okay. And then now we have found the foci, we found the vertices along the major axis, and then we look at the ends of the minor axis. Ends of the minor axis. Right, ends of the minor axis. Ends of the minor axis. So now the minor axis, you're going to take the center, which is 0, 0, and then moving horizontally because the minor axis is the x-axis. So you're going to take the center and then you're going to affect only the x coordinate of the center. So starting with 0, you're going to actually affect with the small one. So the small one is the b. So you're going to add or subtract 2. And therefore, it is plus or minus 2 and 0. Okay. So now we are at liberty to sketch very quickly and easily. So now the center is the origin. So this is the center. If that is the center, then the major axis is the y-axis. Meaning it's going to be like this. Y and x. The foci would be at this one. Okay, the vertices will be at 5. And then would be at 0, 5. Right, would be at 0, 5. And then 0 minus 5. The minor axis would be at negative 2, 0. And then 2, 0. Okay. Then the foci would be the square root of 21 minus the square root of 21. Like this. Okay. Like that. But you see, the way we state the foci, then we must have some coordinates. So which means that it's going to be 0, the square root of 21, and then 0 minus the square root of 21. All right. Like that. And then the center is the origin. The foci is this one. The one focus is that one. The other focus is this. The other focus is that one. All right. So now this is what the ellipse is going to look like for the foci, the vertices, the end, what you call the ends of the ends of the minor axis. Okay. Okay, now let us look at the next question. Right, so obviously this one is easy. If you have been given 4x squared plus 9y squared equals 36, we divide by 36 because it must be 1. So we have this one, you divide by 36, or actually both sides of the equation. Getting x squared over, if you divide 36 by 4, you get a 9. You divide 36 by 9, you get a 4, which equals 1. Right. So we continue. Right, so we continue. All right. Right. So now, you'd have exactly the following. So this is the equation of the ellipse. After having divided by 36, then you're going to have x squared over 9. Y squared over 4 equals 1. Okay. This will give us the center. So obviously this one is going to become x minus 0 squared over 9, and then y minus 0 squared equals 1, which means the center is 0, 0. Right, the center is 0, 0. A squared is the biggest one, which is 9. B squared is the smallest, 4. A is 3, the square root of 9 is 3, yet the square root of 4 is 2. Producing the fact that the major axis is associated with the biggest one. Associated with the biggest one. So the major axis associated with the biggest one, meaning the major axis is parallel to the x-axis. Major axis is parallel to the x-axis. Parallel to the x-axis. Parallel to the x-axis. So we continue. So now, you have the following. You have exactly the following. You have exactly the following. So major axis is parallel to the x-axis. So now there are things we need, like you'd need the C for the foci. C is always the biggest one minus the smallest one. A squared is the biggest one, which gives us the 9, minus the smallest one, which is the 4. And therefore, this is the square root of 5. Right, which means the foci will be, actually, you deal with the center, which is 0, 0. And then now you look at the foci, and the foci are subject to the, actually always lie on the major axis. But the major axis is parallel to the x-axis. Right, so you're going to affect the x with the C, which is plus or minus the square root of 5, 0. So simultaneously, you're going to have the following. So you're going to have the vertices. So the vertices are actually on they lie on the major axis. And the major axis, in this case, we've already said is parallel to the x-axis. So you're going to take the center, 0, 0, and only affect the x coordinate with the biggest one. Right, the biggest one is 3. So you're going to plus or minus 3, 0, which is plus or minus 3, 0. And then now there is the ends. The ends of the minor axis. So the minor axis is on the y for this one because the y is smaller. Ends of the minor axis. The ends of the minor axis, you take the origin and affect the y. Affect the y. So in this case, you affect the y coordinate. Obviously, the center is 0, 0, but you affect the y coordinate, which is plus or minus 2, which is 0 plus or minus 2, like that. Zero plus or minus 2. So we continue. We continue. We continue. Okay, let us draw the graph. Let us sketch the ellipse. Our x-axis and our y-axis there. And then now you're going to have the vertices at 3, -3, and 3. The major axis is parallel to the x-axis, meaning this is what you have. The minor axis, or 2 minus 2. The foci are at negative the square root of 5, positive the square root of 5, like this. So the foci are at negative the square root of 5 with 0. Right, so this one is also the square root of 5, 0. So we continue. Right, so this is exactly what you're going to have. So in other words, these things here are the foci. The vertices are there. Minus 3030. The minor axis 0, 2, 0, minus 2. Right. So we continue. We continue. Right. 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 So this is what we have here. Right. Okay, this is sort of the graph. Now, what else is missing? Because you're supposed to sketch and then give the foci, which is negative square root of 5 plus square root of 5. The vertices, negative 3, 0, 3, 0. Ends of the minor axis, 0, 2, 0, minus 2. So we're done. Let's look at the next question. Okay, so here comes the next question. So because this one is x plus 3, 4y minus 5 squared equals 16, then you need to, because this thing must be 1, always, so that you have x plus 3, you square it, you divide by 16 throughout. Divide by this 16 so that it can be 1. Divide by 16. Which is 16, which is 4 squared. So you subtract this one, and then here you'd have 16 divided by 4, which gives us a 4. But the 4 you can write it as 2 squared. A is the biggest one, 4. B is the smallest one, 2. C for the foci is the biggest, which is a squared. A squared minus b squared. Minus b squared. Obviously, here, it is correct to say a squared is 4. B squared is, like, a squared is 4 squared. So you can say a squared is 16, and then b squared is 2 squared. Right, so b squared is what? Is 2 squared. And therefore, like, a squared is 16 or 4 squared. So this is it. Right, so now we're going to have this. So that at this point, you have the a squared, which is the biggest one. The b squared, which is the smallest one. 16 minus 4 is 12. And 12 is 2 to the square root of 3. Right, so we have that. So, right, so that we have this. So which means I'm going to have the foci. Okay, so the foci are going to be first. Okay, obviously to do these things, you need to first find the center. What is the center? Right, we must first find the center. What is the center? The center is -3, 5. Then now, after you got the center, then you can get the foci because we've already got the C. But for us to also get the foci, we must first be able to tell which one is the major axis. Okay, the major axis is probably the biggest one. The biggest one is below x. So which means that the major axis is parallel to the x-axis. It's parallel to the x-axis. It's parallel to the x-axis. So this is what you have. So it means the foci are actually on the x-axis, parallel to the x-axis. Yeah, they are on the major axis, parallel to the x-axis. But then you consider the center. So what is the center? The center is this one. It's going to affect the x coordinates. So the x coordinate is -3, but you're going to add or subtract this one. You're going to add or subtract 2 the square root of 3. And now it goes with the 5. It goes with the 5. Right, it goes with the 5. Right, so it goes with the 5. So we continue. We continue. Right, we continue. We continue. We continue. Right, so we continue. Okay. Now let us deal. Yeah, we found the foci. Let us get to the vertices because now the vertices are going to be on the x-axis. So you deal with the center. The center is -3, but then you're going to affect it with the biggest one. Okay, the biggest one for the major axis and the biggest one is 4. But if the center is -3, you're going to affect with the 4, meaning the vertices are going to be at what? So which means that now at this point, in the same way that you're able to get the vertices here, so you're going to get them at the same way. So you're going to add, subtract. You're going to add or subtract. Right. Right. Okay, that's a good question. What does foci mean? Well, foci means that at this point, if you draw your right, you draw your graph, you'd have the following. Right. Okay. It has to do with the sum of the distances. Right. So now an ellipse is determined. Okay, an ellipse that is, so you can have one focus here and one focus here. If the major axis is parallel to the x-axis, or in this case, it is the x-axis exactly, or we use the word the major axis parallel to the x-axis because the conic section can be like an ellipse that is up here. So you have this. So now an ellipse is always determined by two foci because now this foci, you're able to see that whenever you measure the distance from the foci to a point, these particular distances themselves, so you can move this point. So in other words, this is how an ellipse is determined, because you can move this point like this, and this point will therefore trace the shape. Will trace the shape. But now, how do we determine an ellipse? So an ellipse is determined by two foci, by 2 points that are such that when you mark them and you can put a string like this, then this is going to give the something we call the locus, the geometry, the shape. Okay, the set of all the points that are the points that trace the shape are points that are determined using the red marking. So now you'd have the two foci, and if you put a rope like this, a string, and then now you move it around like this, like a band, move like this, then you can trace the shape. And these 2 points are called foci. These 2 points are called foci. Right, they're called foci. But now, okay, we speak about the foci. Right. So we then continue to then say, in terms of what the foci are. So the foci of an ellipse are 2 points whose summation or whose sum of distances. Okay, sometimes we talk about the distances. The foci of an ellipse are 2 points whose sum of distances from any point on the ellipse is always the same. It's always the same. So yeah, the sum of the distances, this is like shorter and this is like longer. But if you move it like this, the sum of this distance plus this distance is always the same. Because of that, then these points are called foci. But you see, there are many descriptions of it, because you can describe the foci as 2 reference points. Somebody can describe this foci. Somebody can say foci are 2 reference points. 2 reference points that help in drawing in drawing an ellipse. Okay, these are two reference points that help in drawing an ellipse. These two reference points that help, they help because if you mark them like this, and then you take with a rope like this, then this shape is going to become an ellipse. But there is another shape we call a circle. A circle. Right, a circle, we know it from high school, it's very famous, but it's determined by one focus. One focus. And this focus is called the center. Because if you take a rope, you tie it here, and then you measure here like this, you can move like this and you trace, you can draw a circle. How do you draw a circle? You take a rope, you tie it here, and then you take a pen, and then you move it around like this, then you can get a circle. So in other words, a circle has one focus. A circle has like one focus. But an ellipse, to draw an ellipse, you need to mark 2 points. Mark here, take a rope like this and do like this, trace it like this, and then you're able to measure determine the shape that is required. Right, so now we have this. So this one, which is x plus 3 over 4 squared. So you have y minus 5 divided by 2 squared equals 1. Right, like we've already seen that C is what? Okay, we've determined the foci, which is C is 2 to the square root of 3, yeah? C is 2 to the square root of 3, and then the center minus 3, 5. From the center, then you can get the foci. But to get the foci, then you must determine the measure axis. The measure axis is parallel to the biggest one. The biggest one is 4, so it's parallel to the x-axis. But parallel to the x-axis, then the center, the x coordinate of the center is the one that is affected by the C, because it's the x-axis. X-axis, parallel to the measure axis. Right, and then now we deal with the vertices. The vertices also, you take the center, which is minus 3, 5, but it's going to be affected by the biggest one. Right, but now because it's parallel to the measure axis is parallel to the x-axis, then you're going to affect, then the vertices are sitting on the x. Right, so you're going to affect minus 3 for the center, but you add or subtract the biggest one, yeah? But A is 4 and then B is 2. So you're going to add or subtract 4. And then the 5 remains the same. So let us see here. You have minus 3 plus 4. What is minus 3 plus 4? Is actually minus 3 plus 4 is, it's a minus 1. It's rather a 1. Minus 3 plus 4 is 1, 5. And then the other one, because it's 4 minus 3, which is 1. And then there's minus 3 minus 4, which is minus 7, 5. All right. So, right, so you continue. Right, so now the vertices would be these ones. And then the ends of the minor axis. Ends of minor axis. What are the ends of the minor axis? You consider the center and then deal with the small one. But the minor axis is parallel, because the major axis is parallel to the x-axis, then the minor axis is parallel to the y-axis. So it's going to be affecting the y coordinate, you add, subtract the small one, 2, which is minus 3. 5 plus 2 is 7. And then 5 minus 2 is 3. So the center, x is minus 3, y is 5. Right, so which means that the vertices would be x equals minus 7, 5. So you do this. And then you also do 1, 5. The ends of the minor axis, yeah? You have minus 3, 7. And then minus 3, 3. So this is a sort of graph. And then where do we see the foci? Okay, so this is the sort of shape that you're going to get. Okay, it's like this, of course. But now then you're going to have the center is this one. Okay, the center is x equals minus 3 and y equals 5. Right, so, okay, we have minus 3, 5. So now, at this point, where do we have the foci? The foci are 2 of them. Every ellipse has 2 foci. Has 2 points that we mark and that are used to trace the ellipse. They said that the sum of the distances is constant. So the foci of an ellipse are 2 points whose sum of distances from any point. Sum of distances from any point on the ellipse is always the same. Sum of distances from any point is always the same. Even if you measure the distance from here to there, the sum of the distance is always the same from any point. Those points are called foci. Right, they are used to trace the ellipse. At this point, it means that if this is the center, you're going to have one focus here. And it is what? Okay, the foci are at this one. So this one is going to be minus 3 minus 2 to the square root of 3. Okay, yeah, this is 5. This is 5. Okay, so you have this one. So it's this one together with 5, and then there's another. There's another focus here. So this is minus 3 plus 2 to the square root of 3. What is this? What is this? Right, so which is minus 3 plus 2 to the square root of 3. Okay, so this one is approximately 0.464. So which is this one? Which is minus 3 plus 2 to the square root of 3, 5. That's another focus. So there are 2 foci. There are 2 foci. So this one and this one are called the foci. They're called the foci of the ellipse. But what are the vertices? They are minus 7, 5, 1, 5. The end of the minor axis, minus 3, 3, minus 3, 7. Yeah. The center, minus 3, 5. I think that we're going to take a break. Okay, in taking a break, let's give you one exercise. We're going to come back in the afternoon. Okay, now try this one. This one is a home activity for you. It's a home activity for you. So you try 5D. Right, so you try 5D is the E. Okay. Right. Okay, you're still confused about how to get the foci. To get the foci, you must first get the center. You must first get the center. Let me see what, if there's E here. Okay, now you see the next one is it's just a parabola. Okay, now let us get the foci and then you'll get the rest of these. So how do you get the foci? First, you must get the center. What is the center of this? So if you have 1/4 x squared, 1/9 y plus 2 squared equals 1. Okay, normally we write it as x squared over 4 y plus 2. So I'm just going to get the foci for you, then you'll get the rest. Right, to get the foci, you must first get the center. First things first, what is the center? Because it starts from the center. The center is going to be 0 for x. It's going to be 0 for x minus 2 for y. 0 for x minus 2 for y. Then you must get a squared is the biggest one, 9. B squared is the smallest, 4. A is 3, B is 2. Take the square root. After you got this, then you must get C. The biggest one, A squared minus the smallest B squared. What is the biggest one? 9, the smallest one, 4, which is the square root of 5. Which is the square root of 5. Which is the square root of 5. Okay, so after you got this one, because now since A is 3, then it means that now the 3 is saturated with the Y. It's from the Y, it's from below Y. This means that the measure axis is parallel to the biggest one, Y. Y has the biggest denominator. So which means that the measure axis is parallel to the y-axis. So which means that now you're just going to take the center. The center is 0 minus 2, then it's going to give us the foci. So now because part of the y-axis, then this thing is going to change the y, which is minus 2. So you're going to change, you're going to plus or minus the square root of 5. So this will give us the foci. This will give us the foci, which is this one. 0 minus 2 plus or minus square root of 5. Obviously, we shall do more problems. Please now, you need to try and sketch this one. Try to get the vertices. Try to get the vertices, which are 2 of them, and then the ends of the minor axis as well. Right. Right. We thank you for joining us. It was awesome having this discussion. We're going to continue. Yeah. Okay. Maybe we can try now. But it's enough. Can give you homework. Right. We're going to look at the next one. Right. I think that this is enough for today. It's enough for today. It's enough for today. All right, well, thank you for joining us. It was awesome having this discussion. Until in the afternoon. Shall meet again in the afternoon. Shall discuss the time on WhatsApp. I'm going to send you some times on WhatsApp and then we shall discuss. But yeah, you can practice by finding the vertices of this one in 5D and also the vertices and also the ends of the minor axis and also sketching this one and also sketching this one like we've done. Okay, so now we thank you for joining us. We shall give you more problems to do. Let me see if I can give you more homeworks. Okay, I can give you more problems to try. Can give you more problems to try. Right. Can give you more. We can give you more problems to try. Okay. This one. Here are the problems, the exercises. So we go on to say, find the foci. If we give you x minus 2 squared divided by 9, and then y minus 3 squared divided by 16. Find the foci of this one. Okay. So try that one. And then also, let's give you some exercises, more exercises. Right, let's give you some. Find the foci number 1. Find the foci if it is the following. Right, if it is the following. X plus 3. Let's see. X plus 3. And then this one. Right, so. Right, number 2, also you can try 4x squared. Plus y squared is 36. Number 2. Number 3. You can try these 2 problems that can come in the test. 9x squared plus 4y squared minus 18x plus 24y plus 9 equals 0. Number 4, 5x squared plus 9y squared plus 20x, 54y equals minus 56. Okay, so you have like these problems to find the foci. Right. You find everything, like you find the foci, the vertices, and the ends of the minor axis. Yeah. You have 1, 2, 3, 4 problems. Maybe we can give you another one. Can give you another one. Number 5, which is x squared over 16 plus y squared over 9 equals 1. Number 6, x squared over 25 plus y squared on 4 equals 1. Right. So you have 6 of this, and then you try everything we've put for you. We try everything we have given to you. You also try to find this one, x plus 3. So this is number 7. You can write here number 7. X plus 3 squared plus 4x, y minus y minus 5 squared is equal to 16. Okay, you find the foci, you find the vertices, and also the minor axis endpoints. Okay, right. Thank you for joining us. We're going to meet again in the afternoon because we're going to be having another class now at 10 o'clock. So, right, we are going to be planning for the next class at 10. So now we're going to meet again in the afternoon, and then we can spend more time and do more problems. Okay, we're taking a break now so that you can do another subject, and then we're going to be right back in the afternoon. We're going to give you some times in the afternoon, then you can choose. You look and see. For example, I think off the top of my head, let me see, in the afternoon, if we're going to have 10 to 12, yeah, no, we're going to have, 10 to 12. And then we're going to have 2 to 4, and then let me see, 4 to 6. 4 to 6. Yeah, think about 4 to 6. Okay, we can give you 4 to 6, or we can give you 12 to 2. 12 to 2. Yeah, so you see, if we do 12 p.m. to 2 p.m., yeah, or we can do 4 p.m. to 6 p.m. Not only this, but then we shall go on to do the evening. Yeah, the evening would have to be we're gonna give you provisionally. See, the 8 p.m., 10 p.m., it's a weekend today, so we can do this one. Or if this one is not possible, then we're gonna do 10 to 12 a.m. So think between 12 and 4, 12 to 2, 4 to 6 p.m., and then we can do 8 p.m., but sometimes we have the school, so it will depend on the school. If the school kids are there, then we're going to move from 8, the one from 8 to 10. We're going to move it because the school kids normally sometimes are active on the weekend. So if I have committed ones at 8 to 10, then we're going to do school. And then if they're there, then from 8 to 10, then we're going to move it to 10 o'clock in the evening. So you choose 12 to 2 or 4 to 6. Okay, we're sending you this recording. Right. Thank you so much for joining us. We're sending you this recording, and then you think about this, and you're going to let us know on WhatsApp. But thanks for joining us. Until the afternoon, take care and goodbye. Yeah, this recording is coming to you. This one is coming to you. This recording is coming to you on Conic sections, no doubt.